Everyone, Dr. Vaughn. I'm going to make a quick video here for you about two specific homework questions that I've received through email and text message. Also an open invitation for any of you that want additional help. Please reach out to me. I can only help if we find a way to get together and discuss what's important and what's bugging you. I'll be happy to give you, the Google Talk number that's posted in the classroom. You can talk to some of your classmates. You'll see that I am very responsive to that, and I'd be happy to talk to you and help you out one-on-one as well. So the first question that came in was about homework 11.3, and it was this question number 2 on the homework. And they give you these summary stats. They don't give you the raw data, and they want you to do both a hypothesis test. It's a single a one-sided hypothesis test because of the presence of the greater than. And they also want you to do a confidence interval. So the easiest way to do this, I found, is to actually use StatCrunch. And even though they don't give you the raw data and they don't give you an immediate link to StatCrunch, you can either go to another homework problem or bookmark the StatCrunch page until you see I actually have this opened up in another tab on my window. Here's just a blank StatCrunch page. And that's all I need. I don't need any data in here or anything filled in. I just need access to the menus that are up here. All right, so the first thing we're going to go through is the statement of the null and alternative hypothesis. So what I'm looking at here is the mu1 bigger than mu2. I'm going to subtract the mu2 to the other side. So this would be mu1 minus mu2 is bigger than 0. And that becomes the alternative. Mu1 minus mu2 is bigger than 0 as the alternative. I'm looking at H1, and I want mu1 bigger than mu2. And the only one that has that is F. And then the null should be the equal side. Now they want us to compute this T statistic, this test statistic. It's a T test because I have 2 samples, and I also don't know what the population standard deviation is. I know the sample standard deviations from population 1 and from population 2. I'm going to take these numbers and I'm going to put them right into StatCrunch. I'm going to need the alpha value for the level of significance, and then it'll tell me not only the T statistic, but also the next question here, the P value. All right, so I'm going to go to StatCrunch. I'm going to go to Stat, T stats, and to sample with just the summary. I don't have the data. So T stats to sample with summary, and I'll enter the sample mean, the sample standard deviation, and the N. So the sample mean, 49.1. The sample standard deviation, 6.5. The sample size, 22. And for number 2, I have 44.5 for the mean, 11.1 for the sample standard deviation, and 17 for the N. All right, so that's just entering the data. You're not going to pool the variances. I'm going to do a hypothesis test with the null hypothesis being equal 0, and the alternative hypothesis being mu1 minus mu2 is greater than 0. And I don't need to, you can only do one or the other. Hypothesis test first, and then we'll do confidence interval afterwards. So then I'll press compute. And in my output window, I have the T-stat and the p-value, and that's what's going to go into my answers over here in the homework. 1.519, I want 2 decimal places, so I'll make that 1.52. And for the p-value, 0.0708, they want 3 decimal places, so I'll make that 0.071. 0.071. All right, so now the conclusion, P is, we're going to compare that to the alpha. P is 0.07, alpha is 0.01, P is not less than alpha, P is not low, so therefore we do not reject the null hypothesis. Do not reject, and if you do not reject, there's not sufficient evidence. Now we're going to do the confidence interval. So I'm going to come up here. I don't think it'll let me actually, oh, maybe. I'm just going to go to Edit, and then I don't have to retype the data in here. And now I'm going to switch it over and do a confidence interval instead, and make sure that it's 95% confidence interval. Make sure that this is set to be the same, 0.095, which it is. All of these numbers should still be the same, and then press compute. And now I get a new window with the lower limit and the upper limit for the confidence interval. And those are the numbers that are going to go in here for lower bound and upper bound. Minus 1.645. And the upper bound is 10.845. And that concludes 11.3, question number 2. All right, now I'm going to close this particular homework window down, and I had another question came in from the homework that I'd like to look over with you. So we're going to look now at chapter 12.1 and question number 2. So here we're looking at this, chi-squared test. It's about the distribution, whether the expected distribution matches the observed distribution. Right, so this is a chi-squared test. I don't really know, how to do this in StatCrunch personally. I usually use Excel, but I'm sure that we're going to be able to figure it out. It's a goodness of fit test, chi-squared. And so we'll be able to look in here. I need to put in the observed values in a column. I need to put the expected values in a column, and then I'll be able to compute the results. So, okay, let me close that down. I know what I need to do now. And we'll look at what the observed versus the expected is. All right, so this is the expected. 13% should be brown, 14% should be yellow. So let me start to type some of this stuff in. Okay, over here, I'm going to call variable 1 is going to be brown. Oh, I'm sorry. Let's just call this the expected. And so 1 is going to be brown. That's going to be 13%, 0.13. 2 is going to be yellow. That's 0.14. 3 is going to be red, 0.13. 4 is going to be blue, 0.24. And orange is next, 0.20. And the last one is going to be green, 0.16. All right, so those are the expected. Now I'm going to do the observed. Usually I'll do these the other way around. I'll put observed first and expected second. I might be able to change this. So now we're going to look at the table of values. Okay, a student randomly selected a bag of colored candies and counted the number. So here's the actual frequency, and then the claimed proportion and the observed proportions. So we need to change these counts of brown, yellow, red, blue, orange, green into proportions to match what I have in the expected. Now, or I can change the observed into the frequencies and change the expected into frequencies as well. Okay, and it sounds to me like that might actually work better. So let me go back and just kind of change this to the observed. And I'm going to just type in these numbers from the table: 63, 67, 56, 62, and then 84 and 64. Now, it'll be handy for me to actually figure out what this total is. If I were in Excel, I could just use a sum function, but I can just add these all up and see how many candies there were in total. So let's do that. I'll use my calculator. 63 is probably a better way of doing this. Plus 67, plus 56, plus 62, plus 84, plus 64 equals. That's 396. And so if the hypothesis is that the claim is that they should be following these proportions, then these computations should be 13% of 396. So I'm going to do the observed. We already count. This one now is going to be expected. Is this 396 times 13%, which is 51.48. And now I'm going to take the 396 candies times 14%. That's 55.44. And 13% should be the 51.48 again. And 24%, so 396 times 24, 95.04. And 396 times 20%, orange, would be 79.2. And 396 times 16% green would be 63.36. So, if those percentages were correct, this would be the number of candies of each color. This is what we actually counted. This is what should have been the case if these percentages were correct. All right, so now I'm going to run this chi-squared test and the null and alternative hypothesis first. So the distribution of colors is the same as stated by the manufacturer, or is not the same as stated by the manufacturer. Sounds to me like that's the one that we want. The null hypothesis is, yeah, okay, it's not different enough. You're not actually claiming that it's uniform. Uniform would be if these distribution of colors were all the same. So now, these expected counts, this is what I actually just was computing over here when I was putting it into StatCrunch. So again, what I'm doing here is taking the total of all these candies, which is 396, and I'm multiplying it by the percentages that are up here. It says to round to 2 decimal places, so I'm just going to type the numbers that I have written into StatCrunch because I already calculated these. 51.48, 55.44, 51.48, 95.04, 79.2, and 63.36. All right, so we see we did that correctly. Cool. Now we're going to calculate this chi-squared test statistic. In StatCrunch, now I'm going to run stat and the goodness of fit chi-squared test. The observed column is called observed. The expected column is called expected. We're not doing all cells in equal proportion. That would be a uniform distribution. And, that's pretty much it. I don't need to fill in any of these other option things. I'm going to say compute. And I get a chi-squared value over here of 17.1686, 17.169 to 3 decimal places, 17.169. The range of p-values. So now let's see if StatCrunch kind of gave us that. They give us the p-value. It's 0.0042. And so the range of p-values 0.0042 is less than 0.01. And because it's less than 0.01, which was our alpha value is 0.05, because our p-value is less than alpha, we're going to reject the null hypothesis. And if you reject the null hypothesis, there is sufficient evidence that the distribution of colors is not the same as it's supposed to be. All right, so that was 2 homework questions, rather long and difficult ones. StatCrunch makes a lot of this easy once you know how to use it. I hope this has been of help to you. Talk to you again soon.